Hey folks, Mr. Dell here. We are looking at operations with complex numbers. This is a problem from CPM's Math 2, Integrated Math 2, and this is from section 8.2.2, number 8-43. It says multiply and simplify each expression. So we'll go through this process. So just a quick reminder, remember complex numbers. So complex numbers are always written in a form of a plus bi, where I is that imaginary piece. And that I, where does that come from? I is derived from the square root of -1, right? Square root of a negative, we can't in the real number system take the square root of a negative, but when we get to the complex number system, we can, and it would become an I. So the square root of -1 is I. So that's where that comes from. So a couple other things that we know then, if I was going to square both sides, right? If I had I squared, that would be taking -1 and squaring it. And remember, when you square a square root, it cancels the square root, right? It's just, it undoes the square root. So I squared is equal to -1. So a couple things to remember when we're multiplying complex numbers is one of them is that I squared is equal to -1. So we can actually simplify an I squared. So we're going to be doing that in this situation of multiplying these complex numbers. So when we multiply 3 plus 2i and 4 plus I, it's like multiplying binomials, right? We would actually use the distributive property. We could actually either use the box method, where you put your 3 and your positive 2i there, and then 4 and positive I there, and then multiply each of the individual components in each of these boxes. So that's a 12, that's an 8i, this is 3i, and you see where I'm getting those. I'm making that 3 times the I, and then I times 2i is 2i squared, right? And then we simplify. So combining like terms, so these two are the like terms. So those are going to be the I component, right? So a 3 and an 8 give me 11i. But then we've got to remember right here, this 2i squared, since we recall that I squared is -1, that really is equal to -2. So now we can combine the 12 and the -2, and that's our real component of this complex number. And that gives me 10. So we end up with 10 plus 11i. So that's my simplified complex number after multiplying those two complex numbers in A. So that's one of the methods. The other one I'll show you here for B is just using the distributive property without the box, right? We can actually just multiply this 2 and distribute it, then take the positive 3i and distribute it. So we'll do it that way. So 2 times 2 is 4. Then 2 times pay attention to the sign, the minus or -3i would be a minus 6i. Then I'll take the 3i and I'll distribute that. So 3i times 2 is positive 6i. And 3i times -3i is -9i squared, right? So if we combine like terms and clean up my I squared, right? So first of all, that I squared, remember, that is the same thing as a -1. So really what we have here is -9 times -1 becomes a positive 9. So I have 4 minus 6i plus 6i plus 9. So if I combine like terms, first of all, I notice that this -6i and the positive 6i, well, those actually cancel. They're 0. So really my final answer would just be the 4 and the positive 9, which is 13. So those two multiply to be just 13. Okay, so far so good. And then if you get that, then I would suggest pausing the video and trying to do C and D on your own before I go ahead and do it, and then come back and watch C and D. So C, I'm going to do the same thing. I'm going to take and distribute this 5, and then I'm going to distribute the -2i, right? So we get 5 times 5 is 25, and 5 times positive 2i is positive 10i. Then this -2i times 5 is -10i, and -2 times -2 makes it a -4i squared. And again, that I squared, we know from over here, I squared is -1. Since that's a -1, now times -4 becomes a +4. So if I look at combining like terms, I have a 25 and a +4, so that's 29. And then notice again, +10, -10, 0 out. So my final answer is just 29. So last one, D. Now this one, we're going to be multiplying just variables, right? A times A times negative BI, and so on and so forth. And then positive BI and distribute that. So let's go and do that. A times A is A squared. A times negative BI is negative ABI. Just multiply it out like a string of multiplication. And then BI times A, again, be positive, and I'll put it alphabetically ABI, because BI times A is just a string of multiplication. And then BI times negative BI is negative B squared, I squared, right? The B's multiply to BB squared, the I's multiply to BI squared. And one more time, this I squared is actually -1. So -1 times negative B squared makes it a positive B squared. So if I look to combine, I can see this negative ABI and positive ABI, those are like terms, and they're actually going to cancel because one's negative, one's positive. And so really what I'm left with is just this A squared plus B squared. And that's my final answer there. All right. All right. There you go.